EDX Core Pure, Complex Numbers 1, Introduction, Multiplying Complex Numbers. Here we're going to expand the brackets and expand 2 plus 3i times 4 minus I. So you can use one of several methods to carefully multiply term by term. So I've got 2 times 4 is 8. Then I've got 3i times 4 is 12i. 2 times minus I is minus 2i. And I've got 3i times minus I is minus 3i squared. So I've got 8, which is obviously real. We've got 12i minus 2i, so that's 10i. So they were imaginary. We've got to be careful now. We've got minus 3 times, and I squared is minus 1. So this is 8 plus 10i. Minus 3 times minus 1 is plus 3. So we've got 8 and 3. We can collect as the real part, so that's 11, that's real. And the imaginary part we would write as 10i. Know that I squared will often occur in these calculations, and with practice you will write it down straight away from memory as I squared is the same as minus 1. Something to think about before you go any further would be things like I cubed and I to the 4. So if I squared is minus 1, then I cubed would be I squared times another I. We know I squared is minus 1, so that's minus 1 times another I, which is minus I. I to the 4 you could write as I cubed times another I. We've already worked out I cubed is minus I times another I. I squared is minus 1, and minus minus 1 is 1. So you will in future come across I cubes, I to the 4s, and perhaps even I to the power 5s. Higher powers. What if we expand 2 plus I cubed? So you could do that with a binomial expansion, or you could do it as 3 successive brackets. If it's only 3 brackets, you might want to just write them out and expand them carefully. Once you get onto power 4s and 5s and 6s, you are likely to prefer a binomial method. If we aren't doing this with brackets, don't try and expand all 3 at once. So I'm going to just expand the first 2. So I've got 2 2s are 4. I've got I times 2 is plus 2i. I've got another I times 2, so that's plus another 2i. And then there is I times I squared. So if we look at the I squared first, we know that I squared is minus 1 plus the 4 gives me 3 for the real part. I've got 2i plus 2i is 4i, and now we're ready to multiply by the next bracket. So again, pairing terms up as we go along. We've got 2 3s are 6. We've got 4i times 2 is 8i. 3 times I is 3i, and then 4i times I is plus 4i squared. Again, if we look at the I squared first, we know I squared is minus 1, so this term is minus 4, plus 6 is 2, and then we've got 8i plus 3i is 11i. So here's a little problem, just a little bit more sophisticated now. We've been told that z is 2 minus 3i, and we've got to try and write z plus z squared in the form a plus b root 3i, where a and b are integers. So this is a little bit more structured, a little bit more like an exam style question. So we're going to start with z plus z squared. What do we know about z plus z squared? Well, I know that z is 2 minus root 3i, and we're going to add on z squared, which is 2 minus root 3i all squared. So we've got 2 minus root 3i, which I'm going to leave for now, plus, and now we need to expand this bracket. So this is going to be 2 minus root 3i times another 2 minus root 3i. So just put in plenty of working in here as we get used to this new idea. So I've got 2 times 2 is 4. Minus root 3i times 2 is minus 2 root 3i. I've got 2 times minus root 3i is minus another 2 root 3i, and then I've got minus root 3i times minus root 3i is plus 3i squared. So starting to write it without the brackets and collecting things together. So let's start with the I squared. We've got I squared is minus 1. So we've got minus 1 times 3 is minus 3 at the end, plus this 4 is plus 1. We've got minus 2 root 3i minus another 2 root 3i, so collecting these like terms together is minus 4 root 3i. And now we're ready to pull it all together. We've got 2 plus 1 is 3. We've got minus root 3i, minus 4 root 3i is minus 5 root 3i. And we've got it in exactly the form they wanted. So A is 3, B is minus 5. We've got the root 3i as they asked. In the next session, we'll be looking at dividing complex numbers.